All right, so as we look at lesson 11, it says fractional multiplication and the products of decimals. So we're not breaking out into groups and presenting this, but the basic concept behind it is we're looking at calculating certain things, right? Product means the answer to a multiplication problem. Um, so as we look at these, the only thing I really wanted to teach you with this is the concept of rounding in order to be able to do some like mental math. Let's say you don't have a calculator available for whatever reason. Rounding will help get you pretty close to the answer, and then we'll actually use a calculator to explore the correct answer. And again, remember, I always let you use a calculator in my class because I believe it's a tool, and the key is you need to be smarter than the tool you're using in order for it to be useful to you. So um, don't worry so much about this top section here. All you're basically doing is you're just explaining how you can get close to the answer without a calculator, and then the actual answer itself with it. So as we look, 3462, 34.62 is pretty darn close to 35. If we round to whole numbers, it would be 35. And in fact, it's above 34 and a half, so it'd be 35. We also noticed that 12.8 is pretty close to rounding to whole numbers to the number 13. So if we look at this, we can do 35 times 13 and come up with something that's pretty close. If we look in each one of these cases, we rounded up, meaning we got a slightly larger number. So when we get our total or our final, keep in mind this 35 is bigger than what it actually is. It's 34.62. And this 12.8 is, or excuse me, this 13 is bigger than what it is. It's actually 12.8. So we know that when we get an answer, if we round both of them up, right? Like we did here, we rounded both the 34.62 up and we rounded the 12.8 up. We know that our answer is going to be, since we made both those numbers bigger than they actually are, the answer will be bigger than it actually is. And so we know it can't be anything more than that, but it should be something close. If you look here, we're rounding just a little bit, right? We're rounding 0.2 on the end, and we're rounding less than zero point 0.4. We're rounding 0.38 on the first one. So either way, we're not talking about rounding, by 10 or 15 or 45 or something like that. We're rounding by, less than one whole number. So it should be relatively close. Now that perspective changes as each one of these numbers gets bigger. Any tiny rounding starts to be multiplied or starts to get larger. So as we look at this, we can also then, without a calculator for a minute, we could break down 35 times 13 into, let's say, 35 times 10 and 35 times 3. And we know that 10 plus 3 is 13, so we can get these numbers back. So if we look, 35 times 10, well, anytime you multiply something by 10, you just add a 0 behind it, right? Or move the decimal. So it would be 35 with 1 0 behind it. We see the 1 0 right here, so 350. And then 35 times 3, we could even break 35 times 3 down into a 30 times 3 and a 5 times 3. 5 times 3 is 15. 30 times 3 is 90. 90 and 15 together is 105. And if you look, when we add these two pieces back together, we end up getting 35 times 13. We would add these two bottom numbers. Since this is the same, this remains this one piece here. And these are the two numbers we're adding to get to 13. 35 times 13, in this case, would be a 5, and a 400. So 455, keep in mind, like I said, we rounded up on both of them. So it cannot be bigger than 455. In fact, it should be a little less than 455. And if we use a calculator to double check our answers, 34.62 times 12.8 is 443.136. Our actual exact answer is, where's my pen here? Here it is. 443.136. And you can tell that that number is less than this number here because we rounded up. You can see that 443 is pretty darn close to 455. Like, we're able to get, within essentially 12, right? Or pretty close to like within 10 of it, which is not bad without a calculator. If we want to be more precise, we could even take this 34.62 and multiply it by 12, and then do the same thing, multiply by 0.8, and then we could break this piece down into a 30, into a 4, into a 0.6, and into a 0.02, and do each one of those pieces and come up with the exact same answer, and we would eventually get to this. For today's purpose, I simply want us to get close, and so we're going to do some rounding in order to get kind of close. So looking at the second one here, it says Xavier earns $11.50 an hour by working at the grocery store. Last week he worked for 13.5 hours. How much money did he earn? So we're looking at $11.50 times his 13, that's per hour, times his 13 and a half hours. So we can break this up into two pieces again, right? So if we have the 13 and a half, we could break it up into individuals. We could also drop around stuff, right? So if we have an 1150 times 10, right, we could break up 13.5 into a 10 plus a 3 plus a 0.5 or 1 half, right? So 1150 times 10, all we're going to do is move the decimal in space, so that's $115. We would have 1150 times 3. Well, 3 times 11 is 33, and then 3 times half, right? 0.5 as money is like half a dollar, right? 0.5 is like half a dollar. So 3 times a half is 1.5. So I've got a 33 from the 3 times 11, and then another 1.5. I've got 34.5 or $34, and since we're talking money, 50 cents, 34, that's a 4. And then my last one is going to be 11.5 times 0.5. Well, when you multiply something by 0.5, when you multiply something by 0.5, it's the same thing. It's the same as taking, so if I take a number times 0.5, it's the same thing as taking that number and dividing by 2. Because remember, 0.5 as a fraction is 1 half. And from what we learned when we multiply and divide, when we divide fractions, all we do is we flip the decimal from divide to multiply, and then we flip that second number, right? The top number comes to the bottom number comes to the top. So you can see this divide by 2 is really the same thing as divide by 2 over 1, and you can see that that fraction has just been flipped, right? So what's half of 11.5? Well, what's half of, break 11 down into, what's half of 10? That's 5. What's half of $1? It's another 50 cents. And what's half of 50 cents? Well, 50 cents would be like 2 quarters, so it'd be 1 more quarter. So I get 5 plus 1, or excuse me, 5 plus 0.5 plus 0.25, or I get $5.75. And when I add all these up, 5 and 7 is 12, add a 1 there. I've got 1 and 4 is 5, another 5 is 10, another 5 is 15. Add a 1 there. I've got a 1, and a 3. That's a 5. I've got nothing else to carry, so I've got a 1 and a 1, which is 2. I have $255.25, which if we bust out the calculator on this guy, I have 11.5 or 1150 times my 13.5 hours is $155.25. Oh, this should be a, excuse me, that's not a 1. That's part of my dollar sign. Dollar sign there. So this should be a 1. See? There we go. That's why we double checked it. And of course, on paper it'd be a little easier, but it's the concept behind that. So $155.25. So we're going to continue this now where it says calculate the product. So all we're doing is working out each one of these pieces. And again, quick reminder, right, we're going to take these, and for right now, all we're going to simply do is we're going to round these guys. So I've got 324.56. I'm going to round that to 325. And then I've got 54.82. I'm going to round that to 55. So now we have numbers that are relatively easy to work with, mathematically speaking. And we'll break it into pieces, into chunks, then we'll double check it. So 325 times, I'm going to break it into a 50, and I'm going to break it into a 5. And 325 times 5, well, 300 times 5 would be 1,500, and 25, think of it like quarters, times 5. If you have 5 quarters, it's $1.25 or 125. So this is 1625 if we look at this. So this should be 1625. And if you notice, this one here, this line is the exact same thing as times 5, except it's 50. Well, 50 is just a 5 with a 0 behind it. So that means that it's going to be the same trick. We would do the same times 5, 16, 2, 5, and then the 0 behind it would just fall back here as one extra 0. All right. Now when we add these two together, these aren't in line, of course, but we would add these together. So I'd get a 5. We'd add these together. 5 and 2 is 7. I'd add 2 and 6 is an 8. I'd add 6 and a 1. I'm just doing this to keep track of everything. 6 and a 1 is a 7, and then a 1 there. So I have 17,875. And if we were to use our trusty calculator to double check this, again, we know we rounded each one of these guys up. So we know it can't be more than that. In fact, it has to be a little less than 17,875. We get 324.56 times 54.82. I get 17,792, 17,792.3792. And remember, in math class, I want the first 3. Since this is not a 5 or a number higher than 5, we would drop that, and it would just be 17,792.379. That's my exact answer for math. And you can notice this is pretty darn close in terms of where we're at. It's less than 100 off, which sounds like a lot, but when we're talking about almost 18,000, right? 17,000 and change. 100 based on that is not really a huge amount as far as the difference, right? So you can get surprisingly close just by estimating without a calculator. Obviously, like I said, you always get a calculator, but just reminder of that, right? Number 2, Kevin spends $11.25 on lunch every week during the school year. If there are 35.5 weeks during the school year, how much does he spend on lunch over the entire year? Reminder nearest penny since we're talking money. So I have my $11.25 times my 35.5. So I would write this up as 11.25 times 35, or times 30, I should say, and then times a 5, and then times a 0.5. And same thing with the mental math stuff for this, right? So 11.25 times 3. 11 times 3 is 33. 11 times 3 is 33. And then I have a 0.25 times 3. 0.25 times 3. Well, I know that 3, if you do 0.25 times 3, right, that would essentially be like saying 3 quarters, right? 0.25 is like a quarter if you think about it in terms of money. So that would be 75 cents. So that would be a 0.75, right? And so now I have my 11.25 times 3, right? And I get $33.75. And since it's 30 with that 0 there, we just add a 0 behind it, or we move the decimal 1 space and then add that 0. I have $337.50. And then I can do the same thing here. 0.5 times, 5 times 11.25. So 11 times 5, and then 0.25 times 5. 11 times 5 is 55, and then 0.25 times 5 would be like saying I have 5 quarters, each one of these is like a quarter, right? So $1.25, and I have $56.25, 56.25, and then 0.5 is the same thing as 5, it's just with a decimal off, so we'll just move the decimal up a space. So I would get $5.62.5. Keep in mind, since it's money, we're going to round it to 63. And then all I would do would be to add all these pieces up together. So I have a 3 and a 5 in that far right column. That's an 8. I have a 6, a 2 makes 8, and a 5 makes a 3, 13. I'm going to carry the 1. I have 1 and 6 makes 7, and 7 makes 14, and 5 more makes 19. Carry the 1. I have a 1 and 3 makes 4, and a 4 and this 5 here makes 9. And then I have a 3, $399.38. And if we do the math on the calculator, we get 11.25 times 35.5. We get $399.375. So again, $399.375. And remember, it says around to the nearest penny, so that's 2 decimal places, right? So this one, since this is a 5 or higher, this would round up and would get 0.38. And we notice that the math matches perfectly in this case. That with this guy here. And last set before we go on to problem set here, moving a little faster, we're looking at a car that gets 22.4 miles per gallon. The gas tank can hold that many gallons. How many miles can we go? Well, if we know how many miles per gallon, 22.4, and we multiply that by 17.82, that's the number of gallons, we can figure out how many total miles. So again, let's go ahead and round. In this case, we're going to round this one down because it's 0.4. So I'm going to round this down to 22. I'm going to round this one up because it's 17.82. So I'm going to round this one to 18. And then we'll have 22 times 18. And we'll get close, and then we'll actually use the exact math on this next one. All right, so 22 times 18 can be broken up into 22 times 10 and can be broken up into 22 times 8. 22 times 10 is the same number, 22 with just a 0 behind it. 22 times 8, a couple different ways you can do this, but you could do this as a 20 times 8 and a 2 times 8. 20 times 8 is 160, and 2 times 8 is 16. When we add them together, we're left with a 6, a 7, and a 1 here, 176. You could also do this where, you notice how 8 is just 2 less than 10? So we could do 2 times 8, which we said is 16, and then we could take 220 away from that, right? Away from that, and that should work also, okay? Where are we at here? Let's see. So that's where I made my mistake. Let's try this again. Sorry. So 22 times 8 and 22 times 10, that's what makes more sense. So we have this piece here, right? It should be 2 times 22, right? So there's 2 additionals between here and here. So 2 times 22 is 44, and that's what we take away from the 220. So 220 minus 44, that gives us the 176, and that's this piece here. So like I said, several different ways to do it. Totally up to you as to how you sort of break it up, okay? So in this case, all we're gonna do is we're gonna add these pieces together. So I've got a 6, I've got a 9, and I've got a 3. My answer should be pretty close to 396. If you notice, like I said, this one I rounded down and this one I rounded up. So I rounded each one of them. If you look at it, I technically rounded the 22.4 down, and that's a different amount. That's a 0.4 as opposed to the 17.82 I rounded up less than 0.2. So if we think about that in terms of rounding stuff, we actually rounded down a little more than up, which means it should be just a hair bigger than this. Our actual answer should be just a hair, but it should be pretty close since we didn't really round either one more than like half. And when we actually do 22.4 times 17.82, I get 399.168, which 399, 396, that's pretty darn close for without a calculator, right? We're talking decimals for stuff. That's within 3, right? So 399.168, and of course we have to have our units. In this case, it says how many miles, so this is miles, the amount of miles we can go. And our last problem here says the principal of East High School wants to buy a new cover for the sand pit used in the long jump competition. He measured the sand pit and found the length is this, and the width is this. What's the area? So we're going to round. I got 29, and I got 10. If you want to do some quick fast math, instead of rounding down to 29, you could round it up to 30 to the nearest 10, and we would have 30 by 10, which would be 300. We know it's going to be less than 300 because we rounded both of them up, and this one we rounded up even more, right? And if you think about it, we do round 29 and 10. Well, 29 times 10 is 290. So it should be closer to 290. Again, we rounded this one down and this one up, right? So it should be pretty darn close to 290. If we actually do the math on this, 29.2 times 9.8, I get 286.16. And this is what's the area of the new cover, so it's that feet squared. If it's perfectly matching it. If it's not, he may have to order a slightly larger one at 290 or 300, right? But that's the exact area that will need to be covered, 286.16 feet. All right, and we are off to problem set.